All right, our next topic is gamma ray bursters. Obviously, this is a term created by astronomers because we're not very creative. It's an interesting story about how these were found to exist. If you remember back a little bit of history, way back in the 1960s, the US and Russia, or it was the Soviet Union at that time, were in the Cold War. We both had nuclear weapons, we had nuclear missiles all aimed at each other. We were just waiting for somebody to send their missiles and the rest of us would send theirs and then we would destroy the whole Earth. That happened in the 60s through all the way up until the 90s when the Soviet Union fell apart. And now we have all these missiles we don't know who to aim at. But what happened was there was a treaty back in the early 1960s where we would, us and Russia, agreed not to keep testing nuclear weapons. We realized the fallout from them, the radioactive dust, it was causing damage to the environment, and we didn't want to keep continuing this proliferation of nuclear weapons. Russia agreed, and so they had this agreement. But we didn't trust the Russians, okay? We didn't trust the Russians, so we wanted to make sure that they weren't actually testing somewhere in Siberia and we just wouldn't know about it. So to do that, when you have a nuclear explosion, you put out gamma rays. So by this point we have satellites in orbit. So they put satellites in orbit in the 1960s that were orbiting the Earth, but they were looking for gamma rays. They're actually facing towards the Earth looking for gamma rays, because if they could see the gamma ray burst, they would know that a nuclear explosion went off. But what they were surprised about, didn't expect to find, was not towards the Earth, but out in space, there were these random bursts of gamma rays coming up. They last from anywhere from 5 to like 20 seconds, and somewhere in the sky there would just be this burst of gamma rays. And this is what the spectrums look like. This is kind of complicated, and we're astronomers, we're not very creative, so they're just named GRB for gamma ray bursters. And these are different numbers. And you see, the time is in seconds. So when they first came off, we thought, oh, maybe the Russians are testing and we just didn't notice it. But then when they looked at the location where the gamma rays were coming from, they realized it wasn't coming from Russia at all. It was coming from out in space. And you see some of these, most of these are short time scale. This is a few seconds. This is less, that's only 5 seconds. That's less than a second. It's very quick, just a burst of gamma rays. And then some are quite long. This is about a 20-second one, which is what we call long. So we realized there were two types of gamma ray bursters that are very different. There's long gamma ray bursters, and there's short gamma ray bursters. Okay? So the difference is essentially just the length of time. How long does the gamma ray burst occur? And since that time, and starting in the 70s or 80s, we've put satellites up in orbit, gamma ray detecting satellites, because you can't detect them from Earth because our atmosphere protects us from these. And the hardest part was the gamma ray burster would say, oh, hey, there's a burst over there, but it would be over in a few seconds. By the time we turned telescopes, visible telescopes, so we could see what was there, it'd be gone. And gamma ray telescopes weren't very good at pinpointing exactly where it was, not back then anyway. Nowadays they're getting very good at it. So for a long time we were like, where are these coming from? Are they randomly in space? Are they part of our Milky Way? Where are these gamma rays coming from? And so one of the things you do is you watch a whole bunch of them and see if you can plot out where they came from. So from 2004 to 2010, these are where all 500 gamma ray bursts came from. And you see, same thing that astronomers saw, is that they're uniform. They're just randomly over the whole sky. This is the whole sky, this is the Milky Way in the center. So they're not coming from the Milky Way. If they come from the Milky Way, we'd see a whole bunch in here and not much out here. But instead they're coming from everywhere, so we realize they're not coming from the Milky Way. They're coming from things much, much, much further away. So it's coming from stuff that's way beyond our Milky Way. None of these are local events. Okay. So here is 2,704 plotted, even more. And you can see it's pretty much exactly uniform throughout the whole sky. So, question then is, if they're coming uniformly from the sky, then they have to be coming from something far away. They have to be coming from something that's uniformly across the sky. So they kept studying this. And by this point, we had the Hubble Space Telescope, and it was up there in space. And so if you got lucky, a gamma ray burst was close to where the Hubble Space Telescope was, you could point at it and see where it was. And these are where the gamma ray burst came from. Those spots there. This is the Hubble Space Telescope pictures. All these, they look kind of weird, but all these are galaxies. So at this point we realize, oh, it's coming from galaxies. Not our galaxy, but other galaxies throughout the universe. Not only was it coming from galaxy, it was coming from stars in the galaxy. This is similar to when we would look for supernovas. You would just look at a galaxy and all of a sudden you would see a bright star there. Same thing here, but we're looking at gamma rays, and all of a sudden you get a really bright burst of gamma rays. It's just short-lived. Where supernovas, would get bright and it would last for months and then it would fade off and you wouldn't see it. Gamma ray bursts last seconds, which means the gamma ray burst is coming from inside the supernova right when the core collapse occurs. It happens, because remember, that's when everything happens very, very fast. Where the brightening of a star occurs from the whole envelope blowing up, and that can last for months. But the gamma ray burst is actually coming from that iron core collapsing. At least one of these is. Okay? Then we had to figure out what's the other one. That's what creates the long gamma ray bursts. So the long gamma ray bursts, these guys up here, I'm sure you can read that. These are caused by type 2 supernova. And we'll talk about that in a second, okay? In fact, I think that's the next slide, so let's look at that. So what we think is occurring when you have a type 2 supernova, remember you have this iron core collapse right here. And when the iron core collapses, the whole thing collapses. That happens in seconds, very quickly. It's possible that when this collapses, you get a jet of material shooting out from this core. So you collapse, boom, there's a jet that comes shooting out. And that shooting out is shooting out gamma rays. But this happens on the order of seconds, 5 to 20 seconds or so. This gamma ray burst occurs. Then what you're left over with is this black hole. We're going to talk about black holes coming up in the next few chapters. That black hole, because the whole star is spinning, creates a jet going out the poles. That occurred right as the collapse occurred. So all this material, because it's spinning, doesn't go straight in, falls in and spins, shoots a jet of gamma rays right out the end of it. Now you just have to be lucky, or unlucky, you can look at it either way, that jet, you only see it if it's aimed exactly at the Earth. If we were off to the side, the jet would go that way, we would never see it. So the odds of this happening, first of all, you have to have a supernova go off. Second of all, the supernova has to be lined up so it exactly points to the Earth. But you imagine there's hundreds of billions of galaxies out there, each of them with billions of stars. So even though it only happens rarely, we still see it because there's just the numbers are there. Even if 1 out of a trillion stars gamma ray burst, that means we're still going to see several hundred a year, just because there's that many stars in the universe. And that's why we see so many. So these long gamma ray bursts are caused by the type 2 supernova collapse. Now the second one, the shorter ones, the short gamma ray bursts, were suspected, but weren't determined until just 2 years ago. We think it's when you have 2 neutron stars merging together. And this happens very quickly. All right, so stay with me here. Remember, when this blows up, the leftover core can be a neutron star or it can be a black hole, depending on how big it is. But if it's a neutron star, and if we have binary stars, so we have one star, it blows up, becomes a neutron star. Then we have another star that's orbiting it, it blows up, becomes a neutron star. You can end up with 2 neutron stars orbiting each other. And we see this. We've seen this in the universe. We see it as pulsars, and these pulsars are going around each other. Well, when you have two neutron stars are very small. We talked about this. They're only about 10 miles across. But these neutron stars have tremendous amounts of gravity, so they're orbiting around each other. They're actually orbiting around a point in between them, what they call the center of mass of it. They're orbiting around. As they orbit around, they have so much material in such a small area. They have a tremendous amount of gravity. They emit something called gravitational waves. It's just like throwing a rock in a pond. You throw a rock in the pond, you see these waves that ripple out. These neutron stars are so dense that as they orbit around each other, it's like somebody in a pond spinning their finger. There are going to be waves continuously coming out from them. Well, those waves coming out are energy. So it's stealing energy from the system. And so as these stars spin around each other, and some of them are very fast, meaning going around each other in seconds, they spin around each other, they're going to spiral in and get closer and closer together as they lose energy, and then boom, they're going to run into each other. And when they run into each other, they're going to emit a whole burst of gamma rays, and they'll probably collapse into a black hole. Not exactly sure. But you're like, oh wow, this sounds like wild speculation, but we've seen it happen. There is an observatory called the LIGO Observatory. There's actually three of them now, but two of them that detected these. They are, one's in Louisiana, one's in Washington State. And they're really fancy. I mean, they're really cutting edge technology because it's really tricky to do here. But they're